Hi everyone, welcome back to our channel where we provide an alternative view to the common narrative. You may or may not have heard about the Titan, a submersible that was on its way to the Titanic wreck that unfortunately imploded, killing all the passengers on board, including CEO of OceanGate, the company that created the vessel. These passengers are OceanGate CEO Stockton Rush, British Pakistani billionaire Shahzada Dawood, and his son Sulman Dawood, British billionaire Hamish Harding, and Titanic expert Paul Henry Nargiolet. I hope I pronounced that right. The submarine contained 96 hours of oxygen and lost contact on descent. An implosion sound was heard, and the wreckage was found about 1,600 feet, which is about 500 meters. Unfortunately, all 5 passengers were killed.
Is that it?
Yeah, that's it.
So now you have to ask me.
Okay,
So what do I think about it?
so what do you think about the submersible and the event that occurred? It happened on 18 June, by the way. Okay,
Well, we're still learning here.
we're still learning.
So it's a little bit still erratic. But I will basically when I saw the events, I was actually shocked by 2 types of information that was made available.
Yeah.
And the first thing that what I noticed or what was said and sort of put up a red flag was that it is a composite hull.
Mm-hmm.
And then they showed us a number of videos, and you saw some people in an office, and you saw some people behind computers, and then you saw a nice drawing of the Titan, and then some idiot. No, really.
Yeah.
And then said, "Yeah, but you know the tail piece of the Titan is developed and optimized for." Streamlining the whole the submersible vessel. And I thought to myself, what the hell is this guy talking about? I mean, you do streamlining, call it aerodynamic design, but in this case hydrodynamic design, goes underwater, in order to decrease the drag. But it only becomes effective if you have a higher speed or so, not if you go like a type of thing. That makes no effort. So these guys were actually spending time and money on things that were totally unnecessary. But that already showed me that these guys are not an engineer, so I haven't got a clue what they are talking about.
Mm-hmm.
Now, in my previous videos, I've already told the viewers I am a mechanical engineer. And my specialty was structural analysis. And I worked in the arms industry. And I designed composite hulls for rockets and missiles. And I also analyzed steel tubes and steel bulkheads, and you call it whatever is relevant to this type of field. That is what I've done. It was my specialty. And in fact, actually, I did much more complicated material models, like a typical non-viscous elastic material model, which was the propellant, which you can see it's like a combination between a rubber filled with some hard particles inside there. And I don't want to go into that details. The bottom line, I is, all these vessels are for internal pressure. And anybody that tries to use composite in a call it compressive state, shouldn't call himself an engineer because he hasn't got a clue what he's talking about. Now, in his research for this, well, in the preparation of some nice graphics and so on, I did come about some papers of people that were investigating composite materials for deep sea diving. But I'm sorry, composites are not geared for that. It's not an application. You've got to understand your material. Now, if you look at, okay, I'm going to look a little bit away and so on. But the first thing you have to understand is that metals are isotropic, which means actually that the material properties in all the directions are the same. And that means that also the mechanical properties are all the same. Now, if you look at an anisotropic material, which is typical a carbon fiber, you will find that it is not doesn't have the same mechanical properties in the same direction. And what makes a composite material so unique is that you can design the properties in the various directions you want. But a carbon fiber or a glass fiber or a Kevlar fiber and so on is nothing but a strand. You can imagine basically it is like a rope. You can pull a rope and it's very strong, but you cannot push a rope. If you push a rope, then it's very weak. And that is the whole point about composites. So if you want to use the composite material, you have to load it into a tensile direction, so that the fibers are basically pulled and not pushed. If you push it, then you lose the capabilities or the characteristics of carbon fiber or any of these fibers, and they basically, you are depending on the strength of the matrix in which this fibers are actually located or fixed. And in this case, it would be a type of a resin. So this is a totally wrong application of the technology. And what was the guy, the CEO's name? Stockton Rush called himself an engineer and a pioneer and a cutting edge technology. And that guy actually, well, he died unfortunately, or you should actually say fortunately he died, because I mean, he caused directly due to his own incompetence, his own ignorance, and his own ego. He couldn't understand the basic principles of engineering. And therefore, even if these guys have signed waivers for the risk management, they absolve Ocean, this company, from any liabilities. In that contract is null and void, because it's not a question of assuming risk on a knowingly basis. You are basically, as these guys assumed risk without knowing what the real implications are, where the whole system was basically under design, and it's incompetence and neglect that caused the failure of this hull, and therefore the death of these passengers. So I'm not sure if any lawyer wants to pick it up and so on, but this is negligence, 100% negligence and incompetence that governs this type of accident that happened. Now, I just had a typical video that was made available, where the carbon fiber was actually wounded. That is still the resin or the release agent. There you can see the pre-preg carbon strip that are being wound around the manual. And as you can see, these are pre-preg, they are semi-cured type of carbon strips. And as you can see, they are nicely wounded next to each other. And the direction of strength of these fibers are in the direction, the circumferential direction of the tube. Here you can see actually some of the defects on the material surface already, which is a no-no. And then it goes to elaborate on the whole matter. Here's a small table in terms of the strength ratio of various materials. You can see at the top is about structural steel, which is like normal mild steel. It has a strength, ultimate strength of about 60,000 psi. Then you have stainless steel, which you would have liked to use in this type of application. It's about double the strength of mild steel. Then you have a titanium alloy, that 6A1 minus A4 is basically the sort of more popular type of titanium, which is a little bit stronger than stainless steel. And then right at the bottom, or not second from the bottom, you have carbon fiber. And then you have about 360 psi, which is like 6 times stronger than structural steel, normal steel. But remember, it's in the direction of the fiber. Now the last column gives you actually the strength ratio, which means the strength divided by the mass. or multiplied by, divided by mass it should actually be. And then it gives you the strength versus mass benefit that you can achieve. And as you can see, that is where the Kevlar, carbon fiber, glass fiber composites actually shine out, because they have a very light mass compared to their strength. And this is where the advantage lies. And this is probably what they try to, properties, what they try to exploit. Basically. Yeah, all right, so that's the English word for that. But it doesn't work in a compressive environment where all the fibers are put under compressive strength. And this is a point that any engineer should know, especially somebody that designs a hull like that. Now, there were some talks that NASA was involved and some other Princeton University, I believe. But on further investigation and inquiries by the media, it was found that they were lying. They never were involved in the design. Because something I didn't understood, because if the universities and experts were involved in this, they would have known composite material is a no-no for this type of application. In any case, here's another small graph. It shows you the tensile strength of carbon fiber. And it's in the direction, it's given in the properties of megapascals. And right at the top, you have carbon fiber at about 4,900 megapascal tensile strength. That is when it breaks. However, in the same document supplied by the same manufacturer, you can see again, here's the compressive strength of carbon fiber, and that's only 570. That means if you push a fiber together, it will only be able to withstand a load of about 570, and that includes the matrix or the resin that it is situated, because it was basically a bar that they took and they compressed it from both ends. Now, if you also remember, this is about 570 over 4,900. So it's 8 times more strongly in the tensile direction than in the compressive direction. And if I have to explain it on what the forces are on that hull, there are 3. If it was a pressure cylinder, there would have been pressure on the inside, and the pressure on the inside would have tried to increase the diameter or radius of the hull, and as it sort of tries to expand, that induces type of tensile stresses in the hull. However, if the pressure is on the outside, it would like to reduce the radius and thereby reduce the circumferential distance. Circumference, and thereby would like to shorten the fibers, and thereby the fibers are put under compression. Now, as you already can see, there's a huge difference between that. Now, when you have steel, it doesn't matter. Stress is stress. There's a slight difference between compressive strength, and you have different failure modes and failure criteria, but I don't want to really go into that, because then I'm going to talk about 4 or 5 hours or maybe 5 days and so on, and nobody wants to listen to that. So let me stick with the simple basic facts. Now, if you remember also just now, I showed you the video about where the cylinder was wound with the carbon fiber, and the direction of the fiber was in the circumferential direction. But you must also remember there's a third load in this cylinder, and that is the end caps. And as the end caps has a certain diameter or surface area divided by the pressure, can give you the force, and that means it would like to shorten the cylinder. That is the force that you actually see. Now, when it was wounded, there were no fibers in the direction of the to counter the effect of the domes, the dome forces. So basically what it means is that there was no strength in that direction, only pure the strength of the resin. Now, again, if you consider all these items, then you have to ask yourself, what the hell were these guys thinking? I mean, come on, any simple mechanical engineer that knows a little bit about material should have told them that this is not a good thing. You lose the strength-wise in a tensile direction. In a compressor direction, it's half the stress of the stainless steel. It approaches basically, say, mild steel. You might have used your normal mild steel to design this whole thing. All right, so you lose all the benefits of fiber. In fact, actually, if you look at the failure of steel and metals and isotropic type of materials, they are fairly well predicted, have a lots of history, lots of experimental data, so that is well predicted. But if you look at the failure of composites, and that is a lot of dicey story. It's nothing really predictable because you have various modes of failure. And here's a typical failure mode you can see. Those are the strands, the carbon fiber, and the white areas are basically the resins. There you can see how the various resins can bend, a typical like a rope will do, and then finally collapse and lose its strength and have a local buckling failure. Now, here is a finite element analysis of the various modes. This is what I typically did at my work at the arms industry. And you can see how the fibers are put up in layers and that you have interlayer laminar type of failure. So I don't understand. This is not a, you can see this. I'm sorry. These guys should be put against the wall and fired. British shot, whatever. And these guys were totally irresponsible and unknowledgeable and should never have designed it. They got away with murder next. Yes, the hull thickness is about 127 millimeters, which is fairly thick. They probably had a good luck that they reached that, and maybe, I don't know who did the calculations, but you have to have a big safety factor in this respect. So, and if you look at, basic, if you, I don't know again, if you do steel work and you weld, then there are non-destructive testings that you can do in order to verify that what the quality of your weld is. And some of them are actually, X-ray, you can X-ray them and see if there are any voids in the cracks or any inclusions. Then you can also do ultrasonic, and then if an ultrasonic reaches any void and so on, then that's a change in density and it will pick it up. But you can do the same things about composite materials, and that is common practice. Ultrasonic and and X-ray examination are typical test and verification methods to qualify or to investigate any material for any failures that has occurred. And in composites, that is what you have to do. And the claim by the CEO was that they couldn't test it, there is no authority, and this is new technology and all this other bullshit, and it's not. It's flippin' old, established technology that is common practice that could be done. So this company is totally liable for the death of these people. Never mind the waiver that is signed or not. In any case, now I just want to conclude on the mechanical side. Yes, you can develop new cutting edge technology. It's not impossible. Using composite material, it's a no-go. For a simple reason is, if you can establish, yay.
Welcome back.
Yeah, she's visiting us for our second video. Seems to me she likes it.
You just not very happy about that.
In any case, they are the point about composite materials is that you can shape it and form it as you like it. You can design certain directions as you would like to do it. So if I have to think about this, then what you can do is you can, which is not that easy to do in with metals, and that is to have a number of ribs formed on the inside of the shell. So it becomes like call it a honeycomb of a sandwich type with only one skin and not the second skin, or you can add a second skin, and thereby you can generate a certain structural strengths, and you can have tensiles in the internal fibers maybe. But there are various techniques that can use composites where you can use the shape and the properties and the characteristics in a more complicated way to change the stress strain conditions in the hull. A typical example would be the difference between steel and aluminium. Steel, if you have to roll it into a certain shape like an angle iron or so on, that's fairly basic. But we all know we get aluminium extrusions, and you cannot do the aluminium extrusions with steel because steel is not suitable for that type of application. But we do get complicated aluminium extrusions. Now that the same can be done with composites material, and that is when you can actually harvest and improve materials for this type of properties. And then you can go to steel itself or titanium, and you can, well, what we usually do is if we have high internal pressure, what the material can't do is you have cyclic loads, you have a cold cylinder, and then you shrink a warm cylinder on top of the smaller one and puts the bottom one into pressure, but the fibers on the external cylinder are in tensile, and as you load it from the inside outside, you reduce the total compressive strength in the outside cylinder. Now, what has helped is a typical like in a motor where you have the bolts that connect your head to the cylinder head to the body, which are cyclic up and down loaded. Then you get fatigue loads, and the way that you do fatigue loads is you ensure that there is never a transition from tensile to compressive. So if the domain stays in the tensile region and the material never gets into compressive strength, then you get very long fatigue lives. So it's basically sort of prone against the fatigue failure. But there are a lot of other stuff one can do in this regard. And like I said, I can go on talking and talking and talking. But again, this is a no-no what has happened here. So over to you. You would like to discuss something about our nicely PlayStation remote control?
Okay, so it is known that they use PlayStation controller to operate the vessel. First, when you think about it, it sounds quite ridiculous, but these type of controllers actually are used in the military, for example, to control, is it missiles?
Yeah, well, missile UIVs and so on, mostly, yes.
So it's not that odd. It's not that uncommon to hear about machinery that uses this type of mechanisms. Something I'm more curious about is how you can. I understand that these people were adrenaline junkies, or let's say explorers, or something like that. But there's a big difference between bungee jumping out of an airplane, and getting into a experimental vessel that has not really been that there's not really any promises that this is safe. We've spoken about this before, and you said that these people get on board thinking they won't die. Now, again, there's a difference between jumping out of an airplane. If you jump out of an airplane, there's quite a big chance that you'll survive. There's a bigger chance that you'll survive than if you you will die. So with this experimental vessel, the chances of dying is way more than surviving. So what convinces you to get on this submarine? I mean, I found out that not submarine, submersible. Sorry, it's not a submarine. I read on the internet somewhere that, okay, this happened on Father's Day, which is quite tragic. But also, I saw an interview that they basically had with the son's mother and her, is it the Dawood family. So apparently the mother was supposed to be on the vessel, but because the son begged her, to go with his father because it's Father's Day. He took her place. So the son was 19 years old. So part of me wonders, is the father responsible for the 19-year-old's death? I mean, the 19-year-old is an adult, but he's barely turned 19. I mean, you're still kind of like a child. You don't really think about the consequences of making big decisions. So is the father and the mother partially not responsible? Obviously, they didn't cause the death, but there should have been some sort of not responsibility, but more thinking about, the fact that your child, there's a big chance that they would die. So
I think we last time discussed it when we saw actually on TV and so on. At the end of the day, it's everybody's own decision. And yes, you as a parent has a responsibility to protect your child. But at the other side is he's old enough to make his own decision. But again, if in a couple of videos later on, Dave Cameron, who has done like 36 dives to the Titanic, even though he was comfortable doing it. So he thought his vessel is safe. So anybody that listen to these so-called experts, and they have another vessel that successfully dived, but just to lower depth, that they were talking and knowing what they were doing and so on. So he entrusted his son's life into their hands. But as I showed you now beforehand, is that these guys were idiots. They didn't know what they were talking about, and they had a very smooth talkway maybe and convincing, but this is not cutting edge technology. This is like...
That's what I don't understand. Like, how can he have conducted this expedition without knowing that there were no safety checkups? I mean, if you fly on a plane.
See, well, the same here when I saw it the first time. I mean, it's like going into a pipe. Where the pipe is, there's a little bit of a plate where you sit on top. There are maybe thin cushions. That is what I saw. Then there was a TV screen, and then there was this gameplay. Now, I'm sorry, I will never go into that thing. It doesn't matter what stories you tell
Your
me.
logically, it doesn't make sense.
And these guys are successful, rich people. The one guy was actually a British guy that had a lot of experience in doing extreme type of adventures. So he should have known already. No. At least what they should have done is consult an engineer and ask them. A simple engineer, a basic engineer, simple question. He would have already told them, no, that's not going to work.
But was his ego? I wonder if his ego was so big because the CEO, he basically willingly also got on the vessel, knowing that there were no safety checks done. They were lying about NASA. What?
There was one guy, actually, one of the reporters that actually wanted to go it and then withdrew when he saw the vessel. So he was wakey. He was at least responsible enough to understand that this thing is not going to work. So
I wonder if they were all billionaires. So I wonder if a part of it was, bragging to your friends. Okay, oh wow, I saw the Titanic.
Still common sense tells you there's something. I mean, you got to think about this. I only talked about the strength, but firstly, you can think about the PlayStation controller. And then one guy, the so-called engineer, told us how he battled to get the PlayStation 1 talking to the rest of the equipment. Now, technically, it shouldn't be that difficult because each one of them has protocols and commands. So if you know that, then it's easily to... I mean, also do software hacking and so on. So you can spoof the command. It's not that difficult.
It makes me think...
But apart from that, is that at the bottom of the sea, what is the biggest problem?
Pressure.
Yeah, except pressure. Water.
So, okay.
Water. So water, and the biggest danger to electronics is water.
Yeah.
And you got in a sealed container, and you're breathing moisture out. And you got a cold water walls of the environment where the water condensates. And if it condensates, it goes into the electronics, and it shorts out the electronics. Then this guy only had a monitor, which I'm telling you straightforward is not waterproof. The controller wasn't waterproof. So what shows on the LEDs were not waterproof because they were like camping stuff. So I mean, no, unless you had a dehumidifier inside there, which I doubt, because there was no space available. Then and there's no backup. There's no mechanical override. Okay, look at the other videos that we saw about the other vessels. I mean, they were full of instruments, and not digital instrument, button pieces. Press a button.
A ship
Press a
got
button.
more.
Yeah. Mechanical override, mechanical stuff, not flipping electronic stuff.
Manual. Yeah, it was got
So unless you can ensure a totally moisture-free environment, air-conditioned type of low humidity, then you are in danger. Just remember, it's below zero at that depth. Eh? It's ice cold. Ice cold.
I know the ship was, or the submersible was equipped with a few safety mechanisms to ensure those.
Oh yeah.
But none of them have been.
No. So what they had is, because they had a composite hull, they thought they can have ultrasonic or something like that measurements, which means they glue these sensors against the fiberglass, and if it cracks or fans, then it will acoustic. Yeah. It will pick up the acoustic sensor will pick up the cracking noise, because it will be fibers. It will be something like that. And then it will know whether they have failure. What is the most ridiculous type of instrument? By the time you hear that, you're dead.
Yeah.
It has already cracked. You already collapsed. You're dead. What do you want to do with a signal which you received after you're dead? God, no. I don't know what to really to say about this, but this is really like
it's sad thinking that they put their trust in other people. And if you look at some of the YouTube videos trying to explain what happened, majority of them are either marine biologists or scientists. And people look at these videos and they blindly just trust what these people are saying, but they're not qualified. And it comes down to their egos. I mean,
I have to agree with that. So we watched a lot of videos trying to find out information about this. Nobody talked about the composite hulls and even talked about or addressed the matter that this is not a type of material that you use under these type of circumstances. This is not an application for composite unless you make it a complicated shape and you know what you are doing, like not a true sandwich type, but a ribbed size. It's like I don't know how to describe it. It's like a surface, and every 10 centimeter you have a rib that's about this long. So it's very stable. It's like a scrubber. I don't know how to describe it. Unless you do things like that, and then you have to even look at the stability of these ribs as well, and local buckling, and I can talk about this, but it's not going to really help much. So
at the end of the day, it's the families that have to sit with this now. So hopefully they can have some sort of legal.
Actually, did you actually notice this one video? The guy said this thing had a toilet.
Oh yeah.
It had a toilet right at the viewport.
Yeah, it's ridiculous. I mean, they're supposed to be down there for 8 hours. I mean,
yeah. And then it was like
it's like they're prepared to be there longer than they were supposed to.
No, if you open that thing and I saw like there's only a tube with a small. No, I would have said no. Thank you very much. It's not that it didn't have a history. It had a history where the one motor at one time was disconnected wrongly, and they had to adjust the place to hold it like the sideways in order to control it, because the motor was reversed installed. And then you only have one motor, and if you have one motor, it was like keeling over. So if you lose your one motor, how are you even going to get back? How can you travel? Oh yeah, then they had all these ballast steel. Yes, I can understand. You're going to throw it away, but at flippin' least paint it. That it looks nicely. You can have commercial piping as ballast. It's alright. Paint it just so it looks professional, but not a bag of sand or a bag of metal hanging around there at the side. You don't do things like that. Not if your life is at risk at that date.
I heard they also had a few backup controllers.
Oh, some more.
Yeah. So if the one fails, at least they have 5 more.
But what that doesn't help if the
Yeah.
USB connector, the receiver on the other side has shorted out because of moisture in the air. You know?
Part of me wonders if there's more to this story.
There's a lot of war. But that is when cowboys type of do things that they shouldn't be doing.
Americans.
Save money here, save money there, and actually, at the end of the day, I mean, like I said, they invested money on streamlining the shape instead of doing it on the metal. And that was sort of disappointment. But I already knew when they were talking that something is wrong here. But it's sad. At the end of the day, it's as far as I understand, it's the first accident in like 30 years or 40 years deep sea diving. And I mean, if you do things like that, you have to make extra sure. You know, in engineering, there's a safety factor. There's a reason why there's a safety factor, because nothing is perfect. You know, the first thing I learned is tolerances. Nothing is perfect. How far does the real thing deviate from the perfect theoretical value? And that is a tolerance. And you have to always take that inside. And then you only done like a typical textbook calculation. There is places where you have local deformation. So you have a long beam. It's like a piece of paper. It's very strange like that if it's perfect. Bend a little bit and the whole paper collapses. And that is sort of these things. That's some basic practical stuff that, you know, theory and practical are two different worlds. But it is a sad thing. Now nobody wish it on anybody. Luckily, it was like instant death.
Yeah, it's no pain.
They probably didn't even realize it.
The brain takes 3 seconds to realize pain, and it was quicker.
Yeah,
I think
it's like they were probably still excited going onto the wreck, approaching the wreck and so on, and then suddenly that's it.
It was terrible.
Yeah, but it's usually for the people staying behind that is the worst. But
I really hope they can get some sort of compensation for.
well, these guys are rich. They don't need the compensation. They should close down this company and lock up the people because they were negligent. They didn't do their work. They didn't do due diligence. They were negligent. They promoted themselves as engineers without having the necessary skills or experience or whatever you want to call it. So, and I mean, we haven't touched all the items actually, about that screen as well. That was only certified up to a certain point. The guy that refused the CEO that refused the testing by an independent party.
Why?
The lies about NASA and Princeton University getting involved in that. You know, these are all no-nos, and hopefully the families will destroy these guys because that is what they need to be done. They should never work again, never be able to start projects like this again.
Yeah. No, I agree.
Okay.
Okay, thank you. And please share, like, share with your friends, tell your friends. And we hope to see you next time. Until then, goodbye.
Cheers.